The topic we're going to cover today is the first lesson in the unit dealing with exponential functions. Specifically, what we're going to talk about today are the rules regarding the multiplication and division of numbers in or expressions in exponential form. Okay, so let's explore the following. Let's write 2 to the 4th power times 2 to the 3rd power as the product of its bases. Well, 2 to the 4th power means to multiply 2 by itself 4 times. 2 to the 3rd means to do that 3 times. Okay? Now rewrite this expression in an exponential form with only one base. Well, I have 1, 2, 3, 4, 5, 6, 7. I would rewrite that as 2 to the 7th power. Well, what did we just observe? When we multiplied powers with, sorry for that handwriting, with the same base, we added the exponents. We write this rule, and this is the first of our rules, which is product of powers property, is if I have a to the m power times a to the n, I would rewrite that as a to the m plus n. Okay? And the technical definition of that, it's kind of just rewriting what we wrote above, is to multiply powers with the same base. That is a key. Add the exponents and carry over the base. All right, so working through some very simple examples. 5 squared times 5 to the 4th, 5 to the 6th. X to the 3rd times x to the 4th, x to the 7th. 4a squared times 3a to the 5th. Now the only parts that have the exponents are the a's, so I can multiply 4 times 3, which is 12, a to the 7th. Next one, 3 to the 8th. The point there is that 3 with no exponent, there is an imaginary exponent of 1. And the next one, I add x and 2x and get 6 to the 3x power. Now, what is the value of x in this example? Well, the base is negative 4 in parentheses. I have a 5, x gets me to 14, x must be 9. Okay? Now, let's look at a couple of examples where we want to explore where mistakes are made. Does 3 squared times 2 squared equal 6 to the 4th power? Hopefully right now you're saying no, they're not the same base. One is a base of 2, one is a base of 3. So the rule does not apply. And how can you check that? Well, if you just evaluated this under the laws of exponents, 9 times 4 gives you 36. 6 to the 4th power is 1296. And you can see that they're not equal to each other. Okay. 5 to the 3rd times 5 to the 6th, does that equal 25 to the 9th? Again, hopefully you're saying no. This is probably the most common mistake, or one of the two most common mistakes. You carry over the base, not multiply them. So this should have been 5 to the 9th power. Okay? And then the next one, 4 to the 3rd times 4 to the 5th equal 4 to the 15th. And the answer again there is no. You add, not multiply, the exponents So hopefully you realize the answer there should have been 4 to the 8th power. Okay? Now, sometimes you can rewrite the product of two numbers that are in exponential form as a power with one base, depending upon the circumstances. So on the face of it, 2 to the 3rd power times 4 to squared, there's nothing that can be done with that as it's written. But hopefully that you can see that 4 is a number that can be written with a base of 2. Okay? So the base of 4 can be rewritten with a base of 2. Now, we're going to learn in the next lesson an easier way to do this. But what I just want to show you right now is that you should hopefully see that 4 squared is 16, and 16 is the same as 2 to the 4th power. So instead, I can rewrite this as 2 to the 3rd times 2 to the 4th, which is 2 to the 7th power. Okay? So, if one of the bases can be rewritten as a power with the same base as the other, then the product can be rewritten as one power. Okay? All right. Now, we want to explore the next example, which is a division problem. So, similar to what we did at the very beginning, let's take a look at 3 to the 7th divided by 3 to the 3rd, writing that out in what I'll call the long form. Okay? So, 3 to the 7th means 3 times itself. 1, 2, 3, 4, 5, 6, 7, and 3 to the 3rd. Now, since this is all multiplication, what I can simply do is cancel those, and you'll see I can rewrite this as 3 to the 4th. So, what was happening here? The exponents were subtracted. Well, it kind of makes sense. When you multiply, normally things get larger, so that's why we added. And when you divide, things normally get smaller, not always, and that's why we subtracted. So our rule 2, the quotient rule, is when we divide, we subtract the exponents. So we write that as to divide powers with the same base. Similar rules, you're going to subtract the exponents. And carry over the base. Okay? So let's take a look at a few of these examples. And we'll go through these quickly. First one is 8 to the 3rd. Y to the 3rd. 4 over 12. Neither of those are raised to a power. Yes, I know it's a power of 1, but that's not really have any impact on here. So I simplify 4 over 12 as 1/3, and I subtract the other. Okay, the x stays in the numerator. And the next one, I simplify 18 over 12 as 3/2, a to the fifth. Remember, there's an imaginary 1 as an exponent there. Here, I match up my pieces. 3 squared, 5, and 7 squared. All right, I'm not worried about evaluating this right now. Next one, 10 to the x minus y power. Next one, negative 9 to the 7th. If the negative number is inside parentheses, then you have to keep it inside parentheses. Next one is 2/3. Make sure that's in parentheses to the third. We're going to see that in tomorrow's lesson. Now, 3 to the 20th. Similar to what we talked about earlier, hopefully you'll recognize that 27 can be written with an exponent, a base of 3. And, yeah, it's 3 to the third, so I get 3 to the 17. All right. Now, similar to what we did earlier, all of these are going to have a mistake. What's the mistake? No, these are not the same base. Okay. What I would have to do here is convert 8 to the fifth to a base of 2. I'm not going to worry about that right now because you'll see in tomorrow's lesson how that works a lot easier than trying to figure out what 8 to the fifth is mathematically and converting that over. Okay. Next one. No. Do not divide the bases. The answer should have been 6 to the third power. And the another one is no, do not divide the exponents. The answer to this should have been 5 to the 6th power. Now, the last thing I just want to go through is our third rule, which is 0 exponents. And let's look at this in a couple of different ways. Using the division rule of 3 to the fifth over 3 to the fifth, what would I do with those exponents? I would subtract them and get 3 to the 0 power. Okay? Now, if I were to work out 3 to the fifth over 3 to the fifth, and let's just forget what that is equivalent to numerically, I know I would have this. Okay? And actually, if I worked out these numbers, it would be 243 over 243. Well, what does that equal? 1. Well, what you just told me is that 3 to the 0 power is the same thing as 1. And the rule is anything raised to the 0 power is equal to 1. Okay? It doesn't matter if it's a number. It doesn't matter if it's a variable. Anything raised to the 0 power is equal to 1. Okay? So what we covered today was the multiplication and division rules dealing with exponents, and we will keep building on this over the next few days.